In the past few lectures, we have been talking about software inspections. We understand the need and importance of software inspections. And we also know that software inspections are an efficient and effective technique for software defect removal. So in any successful software quality assurance programs, we must have software inspections as a key part of that quality assurance program. Today, we are going to talk about some practical issues related to software inspections. These issues have been gathered by a survey of literature reported over 2 decades. The experiences that successful inspection companies which have successfully implemented software inspections, they have reported their findings, and they are also grounded in the fundamentals of software inspection. Today is the last lecture on this set of lectures on software inspection. So what we will do today is we will discuss a large number of topics, practical issues that help us in starting and implementing software inspections in an organization. The first and the foremost is the issue related to timing. You see, with every activity that is attached to software inspections, we have to allocate adequate time for that activity. For example, there is preparation and inspection meetings. The organization must allow adequate time for preparation of inspectors on the work product and related material, and they must also allow adequate time for holding the inspection meetings. The inspection meeting should be held for a reasonable time. That is, typically 2 hours is a good time to hold one inspection meeting. However, if the material is that is being inspected requires that more time needs to be spent on that, then we need to have subsets of these inspection meetings. That is, multiple sittings would be needed to complete the inspection activity. Or in other words, we can say that multiple inspection meetings would be required to inspect one work product. And so organization must deal with this fact that complex and voluminous work products need time to inspect. Inspectors need time to prepare for them before they can come for the meeting. If proper care is not given to the timing issues, then what would happen is that the inspectors would not be prepared, and as a result, the inspection will not be successful. Another factor is that the moderator should enforce time limits. The meetings, be that inspection meeting or overview meeting or analysis meeting, cannot go for long hours. The meeting should be completed within the assigned time boundaries. However, occasionally that can be relaxed with the consent of the inspection team participants. And if that is the case, then moderator should consider taking appropriate breaks within the inspection meeting. So we are talking about practical issues here so that this inspection process does not become a burden on the participants of the inspection meeting. And the meetings should be held on scheduled times. And there are certain times of day when inspections should not be scheduled. These are like first thing in the morning, or the last activity in a workday, or just after lunch. So scheduling an inspection is also a very important part of moderator's responsibility, and it has practical implications. The next topic that we'd like to talk about is when an inspection is finished. As you know by now that an inspection can be in any one of these three states. It can be in a planned state, or it can be in performed state or being performed, and lastly it can be in a closed state. Now an inspection is in planning stage or is in planned stage. That is the time when the inspection meeting has not started, but it has been initiated. The proceedings for holding an inspection meeting has started. Now when the inspection meeting starts, that is when it transitions to the performed state. And it includes rework also. And when rework is finished and the moderator and the producer agree that all the rework has been done during the follow-up activity and all the defects have been repaired and all the open issues have been closed or resolved, then the inspection would be in the closed state. And so these things, though they on the surface look very ordinary, but are very important, because we cannot consider an inspection to be complete unless all the necessary activities have been completed, all the defects have been repaired, and all the open issues have been either closed or change requests have been written. Since we are discussing practical issues, we will take different issues related to the conduct of software inspection. Now, when we are starting to implement software inspections, a very important question would be what is the best place to start software inspection? That is, what documents should be inspected in the beginning. So the suggestion is that the requirement specification, design documents, code, that is the programs, and user documentation are good candidates to start the software inspection process. That way, a natural flow would also emerge. So if we are going to implement inspections in a project, it would be a good idea to start with the requirements specification. In that way, follow the next step, do the design and have an inspection of the design document, and so on and so forth. A very relevant question that goes with the previous issue that we have talked about is that can some work products be not inspected? That is, can we choose not to inspect some work products? And the answer to that question is yes, but that decision requires intelligent information and data to back up the decision. In other words, you cannot make an arbitrary decision to ignore a work product, or to select out a work product for not holding an inspection. There is risk associated with choosing not to hold inspections, not to perform inspections on certain work products. So safety critical or life critical software, you should not make that decision very lightly, if at all. Ideally, for such systems, you should inspect all work products. But if you have to make a decision, that decision certainly should be well documented, and the reason for arriving at that decision should also be very well documented. In the last lecture, we talked about different roles of the who participate in the inspection process. What we did not talk about is who are the right inspectors. Although we briefly mentioned when we were discussing the moderator's responsibilities. Now is the time to take up that subject or that topic. A domain expert will be far more effective in finding defects than novices. This is very obvious. Experts, however, are not always available to participate in the inspection. Experts are typically senior people who have other management responsibilities. They are most likely to travel for the organization more than younger professionals. They have more engagement with the customers, and so as a result, their availability to go through the formality and rigor of the inspection process is going to make them unavailable for software inspection. However, less capable inspectors may also be able to find defects. Their efficiency and effectiveness may not be as good as that of experts. However, they can be trained and brought up to speed to perform inspections effectively. The decision to select who is going to be on the inspection team should be based on the risk and criticality of the work product. This is not necessarily the safety related issues. These are the criticality of the work product that is being investigated, that is being inspected. Certain work products have major role in the success of the software project. And so if domain experts or technical experts are not available to participate in the inspection meeting, they may be able to contribute and participate in the re-inspection meeting if that has to be conducted. In any case, this is obvious that the effectiveness of people who have knowledge of domain and technical aspects of the work product will be able to find more defects than those who are novices compared to them. There's another thing, another very important practical issue, that inspections are not a very exciting activity. We have to remember that. Especially true for programmers and designers. Designers and programmers are trained to create the designs and programs. They take it as a creative activity. And for them to find defects and using work products, not the computers, is certainly not going to be very exciting, at least for most of them. But we know that inspections work. They help us in identifying defects earlier in the life cycle, and so we should try to make the inspection process as comfortable and as enjoyable as possible. This should not be a very terse and tense activity, because if we do that, then the productivity of participants will not improve, will certainly go down. Because in many cases, the designers and programmers don't enjoy this activity to begin with. To overcome this situation, the organization should help programmers and designers to learn from their errors. And this can be achieved very nicely with the help of inspections. If we allow the programmers and we encourage the programmers to learn in a safe environment, in an environment which is team-oriented, in an environment in which they are not penalized for making mistakes, they will generally learn from their mistakes and from the mistakes of other professionals and their peers. And we also should remember that not all programmers have the same capabilities, but all of them can contribute to the success of a software project. We have to provide additional training to some of the programmers and designers in order for them to participate effectively in the inspection process. And as they learn from their mistakes and their errors and their defects, they will become more effective, and this thing will show in their future work products. One thing is clear, that almost everyone in the professional community, once they publicly learn about their certain defects, they will try level best to not make the same mistake or repeat that mistake. And ultimately, they will start taking pride in their work and their work environment. And once they do that, they will be able to show their work products to their peers without any hesitation. And that's the intent of inspection. That's how the inspections find defects collectively. So we should try to help the programmers to learn from their errors and create an environment in the organization that values learning and cooperation. Some people say that inspections are like paying for incompetence, that a large number or a group of people get together to find mistakes or defects or faults or bugs in a work product which was introduced by one incompetent professional. The fact of the matter is that the best of the breed, the most capable of the designers and programmers, make mistakes. Even and this fact is acknowledged by everyone, not only in computer science and software engineering community, but in other domains as well. The best of the doctors and surgeons can make mistakes while performing medical operations or surgeries. But we have an advantage that if we use software inspections, we can collectively try to find those mistakes that remain in the software work product. Another practical issue that arises is that when you are studying inspections, when you are discussing inspections, it seems that it requires large teams. The fact of the matter is that inspections can be applied in small teams. Small teams do not need to have the formality and rigor that large teams must have. We have discussed quite a bit of formal processes for inspections in this course. But for small teams, the formality and rigor can be reduced. But the concept of inspections should be applied to small teams. It is a fact, as reported in the literature, that a group of people are more effective in finding defects, in identifying faults and bugs in software work products than as compared to a single person looking at them. And yes, many of these roles that we have discussed in the last lecture can be combined. For example, a recorder and a reader can be combined, or in some possibilities the author can work as a reader. And so there are a number of ways to manage these roles in the inspection meeting. And so there is no reason for small teams not to benefit from such a wonderful quality assurance mechanisms that we are discussing. Another practical issue that would be faced by the industry and the companies is, throughout the inspection process, we have talked about the concept and the need and importance of data gathering. The question that would be put to you, do we really need all that data with inspections? And the answer to that, in the beginning, you may not need that. When you are starting off with inspections, trying to convince everyone that yes, this works, you may ignore the data gathering to a large extent. However, if you want to improve the inspection process and you want to have highly effective inspections, you will need the data for analysis. That analysis will show you how you are improving, how much you are improving, and what are the productivity gains, how many defects were found in the inspection as compared to in software testing. And so in the beginning, it may be easier to ignore data gathering, or at least not to gather too much data. But as the inspection process matures within the company, it would be a good idea to start gathering data and to start a database that will help us in future projects, that will help us in improving the inspection process itself. It is also a fact that not all people will accept the use of inspections initially. You would need to show them data, and you need to analyze that data to convince them, to win them over, so to speak. Data and experience will win all the skepticals one by one. Learn to understand the concerns of the people who are being asked to use the inspections, and you will be more successful. So you have to start with yourself. You have to convince yourself first that yes, this activity is going to improve our productivity. This is going to find defects early in the project lifecycle. Once you are convinced, you have to win the doubters one at a time. And with the help of data, this will become a lot easier. The doubters will ask you questions like, is the overhead worth it? Does management really support this? Are you sure that they are supporting this? And they'll say, how will the data be used? You need to answer that questions convincingly. These doubts will not be limited to practitioners or technical staff only. The management may have even deeper doubts and issues about inspections because they are going to have to pay for them. And if not convinced, they will not pay for them. And so your first task would be to convince the management of the need and the importance and the effectiveness of software inspection. The literature in software engineering community is on your side. You should have no problem finding evidence in the literature about the importance, the effectiveness, and efficiency of formal design and code inspections and other forms of inspections as well. In addition to that, the inspections coordinator or software engineering process group who is responsible for introducing and implementing software inspections in an organization have to stay the course. They must not waver. They must stand on their feet and convince others and continue to convince others that inspections work in finding defects early in the life cycle. Responses must be given to hold the doubters' focus, and eventually the data should win them over also, as I've just said. In this day and age where we have so many publications supporting this very important activity, this should not be difficult. In the earlier lectures of software inspections, I have shown you public data, that is, data which is published in research journals and books, that compares the effectiveness of software testing and software inspections. And you can show that, you can convince yourself that it is cheaper, it is more effective, it is more efficient to find software defects using its inspections as compared to software testing. Now, once you have initiated the inspection process in the organization, some would argue that when a change is made to a previously tested work product, that it is cheaper and less labor intensive to retest rather than inspect or re-inspect. This is an argument that they will make with full force. This argument is false for three reasons. We'll talk about them, what they are. Number one, if a fix or a change is made and previous test cases did not find or flush out that defect, then running them over again are not going to prove that the changes work. If a defect was not found by test, what is the surety that running those tests again will find them again? Those tests will only prove that the changes did not regress the work product. This is not the verification of the change or fix. The test cases need to be changed or modified before running. So it is going for us to rewrite or write additional software tests and develop new test cases to test the changes that have been made. That is reason number one. Reason number two is that when a re-inspection is performed, it is not required to perform that on the entire work product. The change plus the surrounding code may be sufficient to verify the change or repair. That is, if repairs are made in the software code, we do not have to re-inspect the entire work product. We only keep our focus on the changes that have been made and the surrounding areas. And number three, changes and fixes have defects in them also. As you know, when we talked about software quality, we also heard the new term bad fixes. This is what we are talking about. In fact, there is data that suggests that small changes are more defective than large changes. This is a surprising fact. Therefore, there is good likelihood that the defect will be found in test, and now we are back on the very same reason why inspections are better. It is cost effective to find defect before test versus during test. This is an established fact that we have established even here in this course. Another thing is that the inspections are looking at change in the context of the work product. That is, wherever there is a change, we only look at the change as well as some of the surrounding areas. And also, when we are looking at a particular change in a work product, we also link it to relationship with other work products. This we cannot do in testing. This means that the inspectors should ask what else could be affected by the change and try to ensure that the change does not ripple into another defect. And that's why we must ensure that the work products have not regressed. So inspection or re-inspection after changes or inspecting changes is a very important practical issue that is related to software inspections. No one claims that we should abandon software testing. In fact, we are going to start discussing software testing in very near future in this course. We know that if inspections are properly held and properly performed, software testing will be less costly. So we do expect that certain regression testing will also be performed. The tests will validate that the product was not regressed by the fix, and the inspection will verify that the fix is correct and the repair has been applied to it correctly. So these two are fundamentally different perspectives on repairs that can result in damages while we are fixing software code. Another practical issue that one would face is that companies and people and software teams would claim that yes, of course we do inspections. This is our main thing, but they don't work. The question is that it sometimes happens, the concern is that it sometimes happens that an inspection is held as a check mark and not as a quality assurance mechanism. It is given importance that yes, we have held an inspection, but no care or no importance is given in the quality of the inspection. For example, inspections are indicated as having been completed regardless of when they might have occurred. There are certain times and there are certain practical issues on holding inspection and to hold them effectively. If you don't hold them at appropriate time, they will not be effective. They will be ineffective inspections, and the inspection team and the organization will be defeating themselves. This is a self-defeating concept. An organization's attitude about inspection is at best bureaucratic. They think that yes, they have heard and they have some indication from the higher management that inspections are a good mechanism for quality assurance, so they have introduced inspections regardless of the fact that they are not following it correctly and they are not appropriately allocating resources to it. I'll give you some examples as to when this would happen. you can have an inspection after the unit testing has been performed on the code. Now, what's the point of finding defects when unit tests have already been executed on it? And so inspection becomes a non-event. In a second situation or a second scenario would be that the resources are not available for a scheduled inspections. So the work continues without holding the inspection. And the work product that has to be inspected is used as a baseline for further development in a later working stage. An example would be that a requirements document or requirement specification is to be inspected, and for one reason or the other the inspection was not held before the design started. And so you can hold a requirements inspection of the requirements document when the design document is complete. But the point is that it is worthless at that time. You have already built the next document based on that inspection, based on the requirements specification, without inspecting it. So this is fundamentally important, that further development on a product, on a work product, should only be allowed if that work product has been thoroughly and formally inspected. Another scenario would be that some people believe that inspection process will proceed faster if they run tests on the work product before they put through that work product to inspections. That boggles the mind. Why would one have inspections incorporated in that case? If you don't want to really apply the technology or the technique, why would you want to just have a check mark sort of situation? This is, a very typical scenario where you can buy a very wonderful car and have some animal cart pull that car. That's not the intent of the car. So one wonders why inspections are held in the first place. Primarily because management's decision has to be satisfied without actually buying into that decision. And as a result, what happens is that people suffer. Lot of time is wasted, lot of resources are wasted, and no benefits are gained. This is a situation which we must avoid. There is no point holding inspections like this. Another practical issue, and that is also a very strange thing, but it does happen sometimes, is that if you find a defect using inspections, you must fix it. And you can run into scenarios and situations where inspections have found defects, but the producers have not fixed them or repaired them correctly. Common reasons for this sort of unprofessional behavior are the inspection data was lost, is that the author didn't understand the inspection data. There wasn't enough time in the schedule to make the repairs. And that is why when we were discussing different process activities in the inspection, I had said very categorically and very forcefully that an inspection is not closed until and unless all the rework has been done and all the follow-up activities have been completed, all the defects have been repaired, and all the open issues have been resolved. Another issue that we have briefly touched upon was the issue related to data collection and analysis. Not all people see value in collecting data on inspections. Not all people see value in collecting data on anything actually. But as you know, in software engineering, there is great emphasis on collecting data, developing metrics, and analyzing data to improve the productivity and the performance of all involved. And so, as you implement inspections in an organization, you will start to deal with these kinds of issues. Another concern is that inspections are too formalized. Formalism or formality in and of itself is not a problem. The question is whether the process is repeatedly producing positive business results or not. If so, the formality is fine, is justified. However, if the process is wrong, the process is onerous or inefficient or ineffective, then something should be done to improve the process, to see where the problems are, and to analyze the process. And so the formality itself is not a problem, the process will be a problem. And another issue that you will face, particularly in the beginning when you are implementing inspections in an organization, is many people would say inspections are a waste of time. I think you have been given enough evidence and ample information to counter that argument. Some people would say, yes, inspections are good, but this adds redundancy as compared to redundancy with the test processes. We do not claim on any day that inspections are going to replace software testing. We say that software testing will be more efficient and less costly if inspections are properly used. Inspections are intended to remove defects as early as possible. They are a quality control mechanism. Testing is intended to find defects that leak through the inspection process. And they also are used to revalidate that the delivered solution satisfies the needs of the customers. Because we have different kinds of testings, as we will discuss them, and you already know some forms of testing. With the analysis of data from the inspection and test results, both processes, that is the inspection and testing, can be tuned to maximize efficiency and minimize redundancy while maintaining effectiveness. The objective of ultimately all activities included in the project lifecycle, including inspections and testing, is to develop high-quality software product. And both of these, inspections as well as testing, contribute substantially in that goal. The organization must select a style viewpoint for inspections. If an organization does not have a defined or agreed upon to an accepted style for specifications, design, code, or documentation, or any other documents that are to be inspected, then certainly inspectors are going to have difficulty in understanding, in preparation, and a lot of time will be wasted in disagreements about these logistics things. And so organizations should make agreements on these issues, on these style-related attributes of documents as a prerequisite for effective and efficient software inspections. Some people believe that inspections are less efficient than debugging during execution. Some people believe that debugging within test execution environment is faster and cheaper. However, the literature is consistently suggesting otherwise. For those who are not convinced, ask them to try a controlled study. In some situations, however, there are languages where execution of code during inspection would be very beneficial. For example, the visual type languages may best be inspected by execution and also by looking at the code. And so a combination of these two will be better able to find defects in using software inspection. Design knowledge is required to perform code inspections? Yes, and absolutely yes, but inspectors do not have to be experts in domain knowledge or technical aspects. They must know code and design sufficiently to perform design inspections. The domain knowledge will certainly help them in becoming more effective in finding defects. Also, some people say that only superficial errors are found. That is typically the reason because inspectors do not have the domain knowledge necessary to find the defects in the work product. So again, going back to this concept that inspectors who are inspecting must have some domain knowledge and also knowledge about the technical aspects to be more effective. Some argue that performance characteristics are not addressed in inspections. If this is true, then this may be because performance characteristics were not the focus of the inspection. They should be if that is an important aspect of the software product. If that is an important aspect of the application domain, then focus should be given to performance characteristics while performing or while holding or conducting inspection. Many inspectors have this view that they have this ego problem, that they will suffer from what is known as not the way I would have done it attitude. This issue must be controlled with proper and consistent training across the inspection team members, documented methods, styles, and notations to be used by the producer in creating the artifact. And this will then also help the consumers, that are the inspectors, to read the documents and understand the documents fairly easily. We have already talked about the concept of having less rigorous inspections. This can be done with forethought that it is necessary for the business results, but we also should remember that it is risky. In some situations, informal inspections or less rigorous inspections may be warranted. However, these decisions should not be arbitrary, and review should be made after software testing and customer use to learn if the decision was the right decision or not. There's a very interesting question that you would be asked all the time, and that many successful companies do not use software inspection. The areas, the questions that you need to answer, you need to ask to them and provide answers, is that how much more successful they could be if they had used inspection. What is the cost of success, and what is the definition of success for those companies? If you can answer these questions, if the people who ask you these questions can provide answers to these three very valid questions, then and only then you will be able to convince them. Now, at the end of this lecture, let's just focus on few more things, and what I'll call them as deadly sins of inspections. Number one is superficial commitment for management. Number two, not enough time in the schedule. Number three, resources are not allocated. Inefficient or insufficient preparation for the inspection. Selection of wrong people. Not using data for recording and for analysis. Treating inspections as rubber stamps, that is, performing them after testing or performing them at inappropriate times, like after the design has been completed and you're holding inspections for requirement specifications. Not using trained inspectors, not using entry or exit criteria, and believing that all review types are same. There are a number of review types, like walkthroughs and informal inspections and formal inspections. In our discussions in the last few lectures, we have primarily focused on formal, structured software inspections because they are the most efficient and most effective mechanism for finding software defects. So today, with this lecture, we end our discussion on software inspections. So I hope you perform good on the midterm, and see you then.